Welcome. As you can see here, I pasted in a graph of our function from example 3. So in this example, we're finding instantaneous velocity, and we're told to refer back to example 3. And this is directly copied and pasted from example 3. A rock is thrown upward with a speed of 96 feet per second, and here's its position function. And time is measured in seconds, so time is t in seconds. And here's the graph from GeoGebra, and that's on a separate video. So if you haven't watched that video, I would watch it now, and you should see a link coming up on your screen. It looks like those usual YouTube advertisement links, but it won't take you to an ad. It will take you to the video on how to create this graph in GeoGebra. So now we're going to estimate the instantaneous velocity. That is, we're going to approximate it by using secant lines. And I want to know, and I'm going to mark this in red, I'm interested in the instantaneous velocity here at 2 seconds. Oh, and I should label my axes. This is not labeled. This is time in seconds. And this is t. And this up here is our position function p of t. So position of the rock in feet. So let's start with our first secant line, and I'm going to sketch this other point in blue, and I'm going to find the secant line. So I'm going to estimate, or that is find the average velocity starting at t equals 2 seconds and lasting 0.75 seconds. And I'm actually not going to find a secant line. I should speak a little more clearly there. I'm going to find the slope of this secant line. So when you see it starts at 2 seconds, we say from 2, comma, and it lasts 0.75 seconds. You don't write 0.75 here. That's not correct. We start at 2, and 3/4 of a second later, we add 0.75 to get 2.75. We're going to find the slope of the line within this time interval. So to be clear, let me fix my notation, since I don't know if you've seen that in symbol yet. So t is in this time interval, and that would be here. So here's about 2 3/4 seconds. So that gives me 2 points. The blue x value corresponds to 2.75, and the red x value corresponds to 2. So what are those 2 points? For this, it would be useful to have a calculator. So when t equals 2, p of t, that is the rock, has a position of 128. So my first ordered pair, and please don't confuse this with an ordered pair, this is just telling us the interval that t lives inside of, is 2, 128. Let's do this again. When t equals 2.75, p of 2.75, and if I'm going too fast for you, please pause the video and compute this independently before continuing. That's 143. So the rock at 2 3/4 second is 143 feet above the ground. So that's this ordered pair. So let's recall what we've already learned. The average velocity is going to be 143 minus 128 divided by 2.75 minus 2. Or you can see this is just 143 minus 128 over 0.75, and that'll give you 20. So that means the slope, and I'm not going to sketch it in on mine, but you can sketch it in on yours. The slope of this line passing through these 2 points is 20. Okay, let's try this again, and then let's see if we can figure out a way to generalize this. So this time, we're going to find the slope of the line connecting the point starting at t equals 2 seconds and lasting for h equals 0.5 seconds. So what would this look like? Let's actually sketch out our other point here. 2.5 would be here. And let's go ahead and find this slope. So v average, and I'm going to change this formula up a little bit. Notice I didn't write anything down for my calculator yet, because I want to generalize this a little bit, because I really don't want to figure out points every time and then plug it into the slope formula. I want to make my work a little bit easier. So I know this interval is going to end at 2 plus 0.5 seconds, which I can rewrite as 2 plus h. So now we can compute the average velocity as p of 2 plus h minus p of 2 divided by, and this simplifies to p of 2 plus h minus p evaluated at 2 divided by h. This definitely makes my work a lot easier, and this is what I would use. This is a more general form. Okay, so now let's work this out. So we know that h, I should use purple because this point is written in purple here. H is equal to 1/2 or 0.5. So this becomes the average velocity is equal to p evaluated at 2.5 minus p evaluated, I almost wrote t down, at 2 divided by 0.5. And so we end up, and again, please pause the video and try this on your calculator, especially if you think I'm going too fast. We end up with 140 minus 128 divided by 0.5. And that gives us a slope of 24. Okay, so let's recap. For the first part, for the point in blue, we notice that the average velocity, so that is the slope of this secant line, is 20 feet per second. For the second secant line, which is here, and steeper, and so think about this, if it's steeper, that means it should have a larger slope. It's getting more challenging to say hike up this steeper hill. More challenge is a larger number, so we go from 20 to 24 feet per second. Okay, we're getting a little bit closer to a good estimate of our instantaneous velocity. So now on your own, and using this more general form right here, I want you to find the slope of the secant line starting at t equals 2. This is independently, and ending, or excuse me, and lasting for h equals 0.25 seconds, 0.1, and 0.05 seconds. So please pause the video and find those three slopes. And I'm going to color code these so that when you unpause the video to watch, you'll be able to quickly identify which value goes with which answer. So please pause the video now. Okay, you should have gotten these values. When the time interval lasts for 1/4 of a second, we have an instantaneous velocity, an average velocity of 28 feet per second. When our interval lasts for 1/10 of a second, we have 30.4 feet per second. And when our interval lasts for a 1/20th of a second, we have about 31.2 feet per second as our average velocity. And if you see, these are approximately where those points are located on the graph. Our first secant line would be about here, and our second secant line is starting to get pretty close to the tangent. Here's the tangent we want, and our second secant line is really, really close. And we can keep going. We can do one more just to see if we can get a little bit closer. I'm going to say for h equals 0.001. So right here we can see for this time interval lasting 0.001 seconds, our average velocity is about 31.98 feet per second. And again, I'm using this formula right here that we figured out by replacing the length of the time interval with h. So my best estimate for the instantaneous velocity when t equals 2 seconds is 32 feet per second. And soon enough, we'll learn using the derivative, we'll learn techniques to do this, that the instantaneous velocity actually is 32 feet per second. Right now, you don't have the tools to figure that out, but we will get there. For now, we're going to estimate it by using secant lines that start kind of far away and then getting secant lines that come closer and closer to where the tangent line actually is.